Hi there, everybody. Welcome to another Chem Complete Statistics lecture. And in today's lecture, we are going to be discussing how to create statistical frequency distributions from raw, unorganized data. So this is one of many methods that statisticians can use to start organizing and grouping raw data points to make more sense of them. So that is coming up on the channel right now. So before we get started here, just a reminder that you can head over to chemcomplete.com and check out all the free resources that we have available for you. And it's also a great way to support the channel with some of the very affordable paid guides. So let's get started in talking about frequency distribution. So the first thing that I wanted to bring up or mention is the concept of raw data. Now, most people probably have heard of raw data or have some idea of what it is. It is essentially just the unorganized data that's going to be in its original format that the statistician collects as they're going around and doing their research. So typically we will record all of the data. It's not going to be highly structured or organized into histograms or any type of testing situation initially, and then we have to sort through it and make sense of it. Now, a lot of this is helped nowadays through computer programs and software such as SPSS or SAS. And if you have ever used those, you know how powerful they can be. So a frequency distribution is one of the methods by which we can organize this raw data, and it uses something called classes and frequencies. And this is pretty simple to understand. It's not overly complicated. So we'll start by taking a look at an example here. So you can see in this example over on the left, I have the age of the 50 wealthiest people, and you can see the ages broken down there. There's a total of 50 data points. There's 10 rows and 5 columns with the data. Now, over to the right, you see where it says class limits, tally, and frequency. So this is how you would go about setting up a frequency distribution. And in this case, all of the class limits have already been predetermined. So I've put those in there. Now we will talk about, after we go through this example, how a statistician would go about determining the class limits, how to break them down so that they're reasonable. There's a couple of rules or points of advice that I will give you in order to help you create class limits. So what you see here is the class limits starting at 27 and then going up to 35. That is the first class limit that we have. And then from there, it goes 36 to 44, 45 to 53, and so on all the way up to 98. You should also take note, and we're going to discuss this later in the lecture, that there are no overlaps between the class limits. So if somebody is, let's say, 35, they fall into that first class limit, and then 36 starts the new one. So you do not want to have overlaps in your class limits where a data point could end up being technically put into two different classes, or you have to make a decision between them. Now, you can kind of get into situations like that with boundaries, but we'll talk about that more as we move along here. So what you want to do with this data set is you want to go through and you want to make tallies for any of the markings for groups of data points that would fall within that class limit, and then you'll get the total frequency from that. So the tally really is just kind of you're going along and you're counting there. Okay, so what I would suggest that you do is that you pause the video and you attempt to do this, but I will help walk through the first two class limits. Then I strongly encourage you to pause it, try to fill in the others yourself, and see what you end up with. All right, so if we are searching here, you go through the data, and it may take a minute, okay? It's usually helpful to cross things out as you're moving along, if that's possible. So what I would do is I would look here, 27 to 35. So anything that's 20 or 30, I will take a look at a little closer just to make sure it doesn't fall in this class limit. And if it does, I'll make a tally. So if I look at the first row, I've got 40, 60, 50, 80, 90, 50, 70, 50, 40. And so I'm just going along quickly. And then I see 27 here. So 27, I can cross off of the list, and I will put a tally mark right here showing that I have come across one that belongs in that class. This helps you as you're going along to keep track of it, because the more you cross out, it can become difficult to go back in and start searching and figuring out which ones you crossed out earlier. Okay, so if you go through the rest, and for the sake of the time on the video, I will let you know there's only one, which is that 27 that falls within this limit. Now, if we continue forward to 36 through 44, now we are going to look for 30s and 40s. So I can see here's 45. That would fall into the third group there, the third class limit. So I'll ignore that one. 46, same thing. 60, 50, 80, 48 would fall into the third group. And I'm continuing forward like that. So as I'm scanning along, just try to follow with what I'm doing here. Here is a 44. So 44, we'll cross that out and we will make a tally mark over here. Okay, continue forward. Here's 46. No, that would be in the next group. Continuing forward. Here's 45. That's close, but no. Okay, moving forward, moving forward. Here's a 38. So 38 would also get placed into the class between 36 and 44. So I'll put another tally mark. And then as I continue along, here's another 38. So that would be placed here as well. And then continuing, I don't see anything else. So the frequency here would be 1 for this group, and it would be 3 for this group. So continuing forward, I want you to pause the video, try to finish the rest of this frequency distribution and see what you come up with. Okay, hopefully you had time to work on that. So the correct answers here would be that you would have a total of 9 that were tallied up in this grouping right here. And then the next group that you had would be the largest one, and there's a total of 15 in that 54 to 62 range. So hopefully you were able to get this, and if at any point you're going through here and one of the numbers that I have does not match what you have, go back through and look at the data set again and see if you can find where you may have accidentally misplaced one for another. You then have the next largest grouping right underneath that. So 63 to 71-year-olds, there was a total of 10 in this data set. And then it's going to start dropping off from there. So we can see kind of, if you can imagine this in your head, if we were to create a histogram, which will be a different video or lecture that we do, that you sort of have a rise, and then in the middle, you're going to kind of have this peaking as far as age of the wealthiest people, and then it's going to decline off as we get older and older. And that's kind of what we would expect for the pattern. So 72 through 80, we had 3 in this particular grouping here. Then it actually jumps back up for the 81 to 89, and we have a total of 7 that you should find in this group here. And then the last one is 2. So there are 2 of them that fall in the 90 to 98 category. So hopefully you were able to come up with that. Again, go back through and just double check if something doesn't line up here with what you have. And there you go, you've created a frequency distribution. So the next thing we want to talk about is a little more focus on these class limits that we have here, because class limits are something that usually you as the researcher are going to have to determine yourself. So how do we actually determine how many class limits do I want to have? How should I set them up? What should be the spacing or the width of the limits themselves? And so let's take a look at that now. So before we go too far into that, I do want to discuss something called class boundaries. And these kind of are close or related to class limits. They are boundaries that you put on the limits as the data can sometimes get a little more complex. So especially when you start getting into data that is not going to necessarily be discrete, meaning you can't count the individual values like age, and you are looking at something that could potentially have decimal points, right, or could be continuous in nature as far as the data set is concerned. So class boundaries are going to be the lower and upper limits that will ensure that we don't have gaps in the data that are going to exist for the continuous data that we come across. So here's an example. You've got a data point of 75.3 when the class limits are found to be 70 to 75 and then 76 to 80. So the question is, where does 75.3 go? Now, a lot of people might go to rounding, and rounding can be important when we're talking about statistics, but you have to realize that if I stop at 75 and then I pick up at 76, that's a whole unit integer. There's technically nothing in between there that is capturing that information. And so boundaries are how we set up a way to basically be inclusive to all of the continuous data that could be present. So for the lower boundary, you're going to take the lower limit and you will subtract x from it. The upper boundary, you're going to take the upper limit and add x to it. So in this case, we are going to go ahead and let x equal 0.5 because 75.3, we're only going out a tenths unit in this data or information. So if we put a 0.5 boundary on the class limits, we should be able to capture what we need to here, right? Now you could run into the same issue where let's say that you're going out to a 100th place or a 1000th place, you would still need to go even further beyond in order to capture that information. But for right now, we're going to let x equal 0.5. And again, you can see the note here. It says you can decide based on the data. All right, so the new class limits with the boundaries in place would now become 69.5 to 75.5, and then 75.5 to 80.5. Now you will notice that 70 right up against 75.5, right? It starts at 75.5 for the lower limit on the other one. So you do have that small bit of discretion where you have to decide where to put it. Usually or typically what will happen is if it is 70.0, 1, 2, 3, or 4, those 5 numbers, so count them out, 0, 1, 2, 3, or 4, okay, 75.0, 75.1, and so on, you would put it into that first class limit. And then if it is 75.5, 6, 7, 8, or 9, you would place it into the second class limit that is leading its way slowly up to the 76 mark, which would be the next thing after the 75.9. Okay, so these boundaries become important when we are dealing again with data that is continuous. So let's now talk about some guidelines that we want to create, all right, for classes. Because if I want to create class limits, I want to have some sort of guidance on what is appropriate in terms of how to set them up. So there's really about 5 things that you want to keep in mind. Some of these are a little easier than the others. The first one makes sense and should be quite clear. There should be between 5 to 20 classes. This would be ideal. If you're going above 20 class limits, you have too many class limits. You're being a little too meticulous with slicing your data apart into these small niche subgroups. And on the other hand, if you are going or dropping below 5 with the number of class limits, you're really kind of grouping too much together. You need to get a little more specific in terms of parsing that data out and setting it up in different classes. Okay, so general guideline, anywhere between 5 to 20 classes should be acceptable. Now, many questions you're going to find in a textbook when you're learning this, it'll typically tell you, it'll say, here's a data set and create a total of 7 classes with equal width or something of that nature, and go from there. But you would make the choice as a researcher, and a lot of that can have to do with the total range of the information. We're going to start talking about that here in a minute. So number 2, you want to attempt to have a class width that is going to be an odd number. So this will give a whole number for the class midpoint. And usually the class midpoint is represented by X, and then you're going to have a little sub M down here. So it'll have an M that's kind of as a subscript. Okay. Now, the way that you would technically calculate XM, which is the midpoint of that particular class limit, is that you would take the lower limit, and then from that you would also add the upper limit, and then because we're looking for the midpoint from those two, you would go ahead and you would divide this value that you get by adding them together by 2. And that should give you your XM. All right, so for example, if I have 72 to 78, let's say that that's the class limit that I set up. If I were to add those two together, I would get 150. And if I divide 150 by 2, I'm going to end up with 75 as the midpoint. Okay, now let's say instead that I did something like 72 through 77. So if I did 72 through 77, and I went to solve for that one, I would get 149 divided by 2. And that's not going to give me a whole integer number. That makes 74.5 the midpoint of that class limit. Okay, so again, you want a width that is an odd number. And a lot of people look at 72 through 78 and they get confused because they're thinking of just subtracting them. But if you count, literally take your hand and count on it and include your first value and your last value. 72, 73, 74, 75, 76, 77, 78. That's a total of 7 values that fall within that range if you're including 72 and 78. And so 7 is an odd number, and that's why we're getting the nice whole number for the class midpoint. Okay, so who cares about the class midpoints? The reason is that midpoints become important when you're getting ready to start doing graphing of data. So even though we're really focusing on frequency distributions in this lecture, when you get ready to start graphing data, midpoints can be extremely important as you're getting ready to start analyzing and looking at things visually. So just keep that in mind as you're setting things up, because many times people want to start graphing their frequency distributions, and it will help you down the road in terms of the way that you're setting things up. All right, now number 3, we discussed a little bit earlier, but I just wanted to bring it up because it is a very important point, which is that classes, okay, plus or minus that one boundary determination, are to be mutually exclusive. Okay, so if you imagine that we went back to the example with age, right? I'm surveying something with age, and I say, okay, with age, well, let's say my first class is 10 to 20-year-olds, and then it's 20 to 30-year-olds for the next one, and then it is 30 to 40-year-olds for the next one, and you get the idea, right? I continue forward from there. So let's say that I had a subject, and the subject that I am studying turns out to have an age of 30. So then the question becomes, well, which class does this subject go into? Do they go into the 20 to 30 range, or do they go into the 30 to 40 range? Because 30 is appearing twice in here. So we really want to avoid having any overlap with these, and it would be more appropriate to do something like saying, okay, I will do 10 through 20, and then my next one will be 21 through 31, and then my next one will be 32 through 42, and so on. All right, so try to keep, or absolutely keep, those mutually exclusive from one another. All right, so number 4, the classes must be continuous even if 0 subjects fall into a given class. So there should be no gaps in the frequency distribution. So this is evident just within the statement itself, but what we are saying is you cannot turn around and take gaps. You can't turn around and say, my first class limit is 10 to 20-year-olds, and then my second class limit is 35 to 45-year-olds. You are then skipping 21 through 34-year-olds, and you don't have a class limit for them. And you'll see it says even if 0 subjects fall into that class, you cannot turn around and take a gap in the frequency distribution like that. Again, this also comes up to grading and graphing and keeping things consistent. You want to make sure that there are no breaks when you're looking at your class limits. Okay, and then finally, the classes must be equal in width, and that's going to also help avoid visual distortion of the data that you are working with. So you have to be careful in terms of saying, okay, I'm going to have a class that's, let's say 10 to 12-year-olds, and then I'm going to have 13 to 50-year-olds, and then I'm going to have 51-year-olds to 57-year-olds, right? That middle class limit is way too large. The width is, many, many times over either of the other 2 class limits that we just mentioned there. They need to be equal in width when you are breaking them down. So how do we prepare these in terms of the actual mathematics? So to prepare class limits, you want to find the range for the data set, which is going to be the highest value from the lowest value. So if you subtract those two from one another, you will get the range. And then with that, you want to find the class width. So the class width will be the range that you get from that data set divided by the desired number of classes. So again, that's kind of up to the researcher to determine the number of classes. However, again, point one is really that you should at least have 5 at a minimum, and you probably shouldn't be going much above 20. Okay, so many problems in class will probably be dictated to you. They'll tell you, but if you are making the choice, if you're doing the research yourself, try to keep those guidelines in mind, and that is how you can determine the width that each of those class limits should span. So that is going to finish up the introduction to the frequency distributions. And we will continue forward taking a look at other ways to graph data and represent data. Some things that you've probably heard of, like stem and leaf plots and histograms and things like that. Visualization and organization of data is very important before we then can start moving into testing and looking at the way things break down, testing whether there's significant differences and all of that other good stuff. So again, head on over to chemcomplete.com for any of your learning needs. Thank you so much for choosing this channel for learning statistics. And I hope that you have a great rest of your day. Like, comment, subscribe, and all that good stuff. I will see you guys in the next lecture.